And we're off. This is section 4.7 in the textbook. It's called Complete the Square. And the goal here is to solve quadratic equations by completing the square. What is completing the square? It's the process that allows you to write an expression from the form x squared plus bx as a square of a binomial. Square of a binomial would look like x plus 2 quantity squared, for instance. So the formula we're going to use for that is written here. Nice formula. It's a little tricky to kind of sort this out, so maybe we'll go right into an example. But they're saying take the b term, divide that by 2, and square it. So what are we trying to do exactly? Well, let's say we had x squared plus 10x. And I would like to get that into some binomial square, perfect square. So the question is, what number do I need here to be able to factor it so it says x plus or minus some number quantity squared? And the rule says, hey, take this b value, divide it by 2. So in our example, that would be divide 10 by 2 and get 5, and then square it, which is 25. So if the number 25 were here, which we just put there, right? Again, how do we do that? 10 divided by 2 is 5. 5 squared is 25. Now if I walked up to you and said, hey, can you factor this? You would be able to factor that into a perfect square. X plus 5 quantity squared. If you multiply that back, you would get x squared plus 10x plus 25. So here's our first example. Make a perfect square trinomial. It says find the value of c that makes x squared plus 12x plus c a perfect trinomial square. Then write the expression as the square of a binomial. So again, using our formula, we would take the 12, the b term, we'd divide it by 2 and get 6. We would square the 6 and get 36, and then that number gets added at the end here. That's what number we would need. With this number 36, we could now factor, right, into, we would take x squared plus 12x plus 36 and factor it into this binomial square. Yeah, nice to see it written out, but most of us would go right to this move, this squared out, but just so you appreciate what we did. Hey, why don't you try these two examples? Again, what would this c value be to allow you to factor in a perfect square, and then factor it? So again, use the rule, half of the b term, square it, and add that. Go ahead and hit pause, and when you're ready, hit play. And here are the answers. So first of all, you should have figured out that half of 24 is 12. Square that is 144, and you would add 144. And then you should be able to factor. Notice this guy is always half of the b term. I don't know if you've noticed that yet. Second example, we would take 10 divided by 2 is 5. Square 5 and get 25. And that would factor to this perfect binomial square. And again, notice the 5 comes from half of 10. Okay, and let's go to the next example. So they're saying, hey, can you solve a quadratic equation, really, and solve it by completing the square? And we're also going to just break the two examples into one case where you have a is equal to 1, and then we're going to make it bigger. Let me increase my view here. So the first thing we need to do is kind of get that 13. Here's the original. I want to move the 13 out of the way. So 13, by the way, we know that you can't factor this right now as a perfect square. So the 13 is kind of it's just a distraction. So if we subtract it to the other side, I can just focus in on the left side, right? So here, this was like the last example. Let's say 10 divided by 2 is -5. -5 squared is 25. I want to have a 25 here on this side of the equation. To do that, I have to balance the equation, and I have to add it to both sides. That's a big step that you remember, hey, if I'm going to put 25 on the left side, I need 25 on the right side. Notice now that the left side would factor to x squared minus 5 quantity squared, and -13 plus 25 is 12. So again, be careful. Always remember, if I'm going to add to one side of the equation, I have to add to the other. And that's easy to forget when you're just trying to solve this equation. What's my next move? So from here you should say, hey, I got it, right? I've already solved these types of equations from section 5.4. I take the square root of both sides, plus minus. right? I would then add 5 to both sides. And finally, root 12, you say, oh, that simplifies to 2 root 3. So in the end, I have 2 solutions, right? And don't forget, there's always 2 solutions when we solve quadratics. X plus 2 root 3, 5 plus 2 root 3, and 5 minus 2 root 3. So here we're going to solve an equation where a is not 1. So we've got quite a hefty equation to solve by completing the square. Luckily, you notice that each of these coefficients are divisible by 3. So I think the first step really is to divide everybody by 3, and then that simplifies the equation x squared minus 4x plus 9. Now again, this 9 is a hindrance, so I'm going to move it to the other side of the equation, right? And now I kind of focus in on this negative 4. Half of negative 4 is negative 2. I square negative 2, I get 4. So I need to add 4 and make sure, again, here it is. We're adding 4 to this side. If we do it to one side of the equation, we must add to the other side of the equation. I get to factor the left side. Negative 9 plus 4 is negative 5. And now we get to take the square root of both sides and look at that, how nice. When we take the square root, we are going to get the square root of negative 5. And from yesterday's class, we are now allowed to say that's going to be I root 5. And the book always has a hard time with that's I. And now you've got 2 solutions. Both are imaginary. These are not real numbers. They don't actually even exist. But we do get to answer, which is quite wonderful. Okay, time for you to practice. So here are 2 equations. Notice this guy is A is equal to 1, but here B is 2. But notice all the coefficients are even. So maybe your first step would be to divide. Go ahead and hit pause and hit play when you're ready. And there are the solutions. So the book tells us the answers are 1 and 7. How did I do it? Well, first I subtracted 7 from both sides just to get out of the way. The negative 8 divided by 2 is negative 4. Negative 4 squared is 16. I added it to both sides. Hopefully you remembered both sides. You can factor the left side. At this point, you're cruising, right? This is just like you guys did on the last test. You would take square root of both sides, get 3 and negative 3, and then you would add 4 to both 3 and negative 3. If you look here in problem 4, the first step for me was to divide by 2. And now you're really into the same problem. I would then subtract 12. I had to add 25. Why 25? Because negative 10 divided by 2 is 5. 5 squared is 25. And off you go, same as last section. And so finally, the last step is, hey, can you take an equation that's written in standard form and write it in vertex form? And vertex form, I don't know if you've noticed, is the completing the square form. So the steps here are to figure out, and the parentheses are nice. They kind of say, look, well, let's just focus in on the x squared plus 14x. I take 14, divide it by 2, get 7. 7 squared is 49. I'm going to put a 49 here and on the other side of the equation. I'm going to factor this trinomial into this binomial squared. Notice this 49 is still hanging out over there, so I'm going to finally subtract him over. And now you can see this is vertex form, right? And the vertex is clearly at negative 7, negative 5. So a nice method to go to vertex form and to find the vertex. Why don't you go ahead and try these 2 problems, and we're almost done. And there are your solutions. So I showed my work here, right? I kind of isolated the first 2 terms with the parentheses. I figured out quickly that 12 divided by 2 is 6. 6 squared is 36, so I added 36 to both sides. Hopefully you remembered both sides. I could then factor the trinomial to x minus 6. And finally, to clean it up, I need to subtract 36 to both sides. Here is vertex form. The vertex is 6, negative 14. And this other example is pretty much the same way. I'll see you in class.